Hi everybody, this is Duke with a video talking about this assignment, filtering. So in this assignment we'll be working on some filtering processes for Ardupilot, and I'm going to try to walk you through some of those steps. I've created kind of just a quick reference for us in this video. I think I might flesh it out a little bit and publish it in Canvas for you guys as well. But this is basically a flow through what we're going to be talking about today, and this will go in conjunction with the assignment here. So the idea here is that we're going to be doing what's called filtering on our Ardupiloters. Filtering is, like it sounds, filtering out stuff that's bad and keeping the stuff that's good, basically. This first page here is a good place to start. You can see I have it open 3 different times now. um, and it talks about managing gyro noise with these specific type of filters. Okay, this paragraph here is important. Okay, well, it's all important, but this is what I wanted to point out right now. Okay, to the autopilot of flight controller, vibration noise looks like any other disturbance. So wind, turbulence, lots of other things going on, right? But what we want to do is, in addition to mechanical vibration dampening that we installed in our flight controller, those little gummies, we want to use software filtering to remove more of the noise or vibrations going on that are not relevant to the flight controller's control of the aircraft. So we learned here that Ardupilot provides 2 different filtering mechanisms for noise. We have low-pass filters on the accelerometer and the gyro, and then we also have harmonic notch filters on the gyro signals. So the low-pass filter is pretty straightforward to set up. We'll set that up quickly, and then we'll talk a bit more about the harmonic notch filters for most of this video. And we'll down here a little bit. Excuse me. There we go. I do recommend you read through this as well. It's got some good information about what filters are for and why we have 2 different types and things like that. Okay. But let's go over to our kind of step-by-step here. So the 2 different types of filters have a low-pass filter and a notch filter. And so a low-pass filter is basically filtering out a lot of noise above a certain frequency, passing over the low frequencies, like low pass. Okay, and so we're going to go through the initial setup of that, which is the emission planner, and then we'll go back to the notch filters. So if you haven't done this in the first class where we built these, you want to do this now before you continue to fly more and more. The initial parameters setup. There's a little tool emission planner. Right now I'm connected to a simulated copter, but it will look the same as for yours. I'm going to go to setup, mandatory hardware, and initial tune parameters right here. Okay. In this area, you're going to put in a couple details. Air screw size or propeller size in inches is 10 for our quadcopters, and we're flying a 4-cell battery. Battery fully charged, battery fully discharged, those are both fine. And we're just using regular LiPo batteries. You're going to hit this calculate initial parameters. Okay? It's going to generate a bunch of values that have to do with tuning and other things on the copter. But one of these values here I want to point out, the INS gyro filter and INS accelerometer filter. Those are the 2 we've just read about a second ago. And you see the default for both of them is 20. But the new value, based on our prop size and our battery cell count, is different. So what we want to do is we hit write to FC. Okay, I'm not going to write that right now because this is not my actual copter, but you'll write those to the flight controller and it will save those parameters just like any other parameter. Okay, so you want to do this with your actual X500 and write those parameters to your copter. That will give you a good base point, and it will also fulfill the step of your low pass filter, setting your low pass filter. Okay, again, you notice both of these are not default. Okay, 20 is default, 10 and 42 are the settings appropriate for our battery count and prop size. So that's the first thing we want to do. The next thing we want to do is go in here and start following some of the wiki steps. We're going to talk about notch filters now. Let's go back over to the wiki. Okay, and they have this notch filter setup overview as well. So step number 1, select how the notch filter center frequency will be controlled. See notch filter control type. So if we click that, it's just a little bit down the page actually, right here. Okay, so there are different ways you can set a notch filter. Okay, and when I say notch filter, let me pull up like a little whiteboard thing here. Hold on a second. All right, so I got my Microsoft, handy dandy Microsoft Paint up here. I'm gonna give you a little visual for this, hopefully. So I'm just gonna draw like a typical graph layout here. And we're gonna have frequency, okay, oops, if I can spell frequency, on the bottom and amplitude on the side here. Okay, so if we imagine our vibrations on our copter in terms of frequency and amplitude, this graph will make sense. So let's say we're measuring our vibrations in terms of frequency and amplitude along this spectrum. So we start at 0 hertz and we go up to whatever the top level of that is in hertz. Okay, so along this spectrum, we have vibration on our copter happening when it's in flight, and the vibration will be kind of graphed something like this. And we have some areas of larger amplitude and some areas of smaller amplitude and things like that. Okay, so we see that there's certain areas along the frequency. So let's say this is 100 hertz. Right here, here's 200. Here's 300. Okay. Apologize for the sloppy write. I'm using my finger. I don't have a stylus for this, unfortunately. Um, but let's say we have these vibrations going on. So generally speaking, our vibrations are, so-so, and then around certain frequency ranges, we get more vibration, or it's a larger amplitude. So in the case of, let's see here, I'll try to use red, a low pass filter will kind of swoop down sort of like this and filter out a lot of the stuff that's present there. Okay, so that's a low pass filter. It's passing over the low area down here, okay, and filtering a lot of the higher frequency noise. Go back here. A notch filter will be applied at a very specific area. So let's say we have a notch filter and it's applied at 100 hertz. So it'll kind of come along here and it will just peak down and go back up and then continue on. It's going to basically filter out just this stuff here and not allow it through. So a notch filter is very specific, whereas a low pass filter is very broad and sweeping like that. Okay, and of course you set these filters to certain frequencies, so they're appropriately set for your copter, for your situation. So you could have a low pass filter that's more like this, or one that's much further. They're different types or different settings, I guess, for the filters. Okay. But if we go back over to the wiki here, we have notch filter control types. So we're going to set the low pass filter like we did in Mission Planner already. We already set that based on our propeller size and our battery cell count. Okay. But now the notch filter is set per other, I guess, things going on the copter, if that makes sense. Okay. This will help the notch filter move around and target specific noise on the copter as it perhaps changes during flight. Okay, a static filter will be just in one spot all the time. Okay, this static filter right here, okay, is one we're not going to use, but this could be used, as it says here, with traditional helicopters, where the rotor speed or the speed of the rotor on the top of the helicopter is always the same RPM. Now with quadcopters, that's not the case. The motors change RPM all the time, so we're not going to use a static center frequency or a static filter. We're going to use a dynamic or moving filter. Okay, but these are different filter control types to move that notch around and target different areas. So if we had a static notch, it'd just be stuck here all the time. Okay, but if we have a dynamic notch, it can move around, so it can move up here, and then it can move back down here, depending on our motor speed, depending on our throttle, depending on lots of other things. So dynamic just means it can move around during flight and during operation. So we're not going to use a static filter. We're not going to use throttle position based. You could use that with our copters, but there's a more precise way to do what we're going to use. If you don't have the ability to know how fast your motors are spinning from some kind of RPM measurement device or from your ESC telemetry or something like that, if you don't have a way of knowing how fast your motors are going, then this would be like the next best thing, basically, because as your throttle moves around, the notch can move around. Okay. We don't have an actual RPM sensor on our aircraft, so there's not an external sensor that's measuring RPM of our motors. And we're not going to be using the in-flight FFT based, mostly because we can use ESA telemetry based. Okay, since ESA telemetry based is basically getting the RPM of the motors back from the ESCs. When we flashed our flight controller, we used the bidirectional D-Shot firmware, which allows the ESCs to receive D-Shot signals from the flight controller, but also to send signals back that can give information like motor RPM in real time. Okay, and so we're going to use ESC telemetry based because it works very well and it's not as computationally intensive as the in-flight FFT, okay, which is a fixed Fourier transform. It's some math stuff. I'm not going to pretend to know how everything works there, but basically it's kind of an onboard live calculation to move the harmonic notch around. You have to have a more powerful flight controller to do that. Now we should have a flight controller that's powerful enough to do that, which with an H7, but since we can use ESA telemetry, we might as well just use this. Okay. So our harmonic notch mode, or our method of operation, is going to be tracking the harmonic notch, moving it around via ESC telemetry. It's going to be a little bit different how to describe here because we don't have a separate telemetry wire. We're using bidirectional D-shot, but this is the mode we will be choosing, ESC telemetry based. Okay, so if we go back over here, we're going to choose notch filter type based on physical hardware, right? Like I said, we don't have an RPM sensor, but we do have ESC telemetry, so that helps us decide our notch filter type. Okay, let's go back up here to the little walkthrough here. So we've done this step. Okay, we're not using a static notch, we're not using a throttle-based notch. Okay, we are next going to enable the notch filter. So if I click on that, it scrolls down to this section here, enabling the notch filter. We're just going to enable one notch filter, so you go into your copter and you will go to INS harmonic notch enable and set it to 1. Okay, so let's go into Mission Planner real quick. Go to the full param list. Oops, full param list, sorry. INS harmonic notch. Okay, and we see they're both disabled right now, which is the default. So if I go into this one and I change it to 1, or I click on the drop down and hit enabled, write params, param saved. You changed a enable parameter, so you need to refresh your parameters. Okay, and it might do that automatically for you. And then sometimes you get errors. I'm not sure what this is. I'm using the simulated copter right now, so I'm not going to worry too much about this. Okay. But we're going to go ahead and reconnect to the simulated copter. It looks like it just disconnected. I apologize. With the real copter, usually that doesn't happen because it's not connecting to the simulated instance. Okay, there we go. And all right, back to the config. INS harmonic notch. Okay, so that first one we enabled it. So INS harmonic notch enable 1, and we have all these other parameters now that have to do with that harmonic notch. Harmonic notch number 2 is not enabled. We don't typically need 2, so we're not going to worry about that. But if you enable that one, you get all these identical parameters, but they'd be for harmonic notch 2 instead of harmonic notch 1. Okay, so we enabled that. That's good. Okay. Once you enable the notch filter, then you're going to select the center frequency control method using INS harmonic notch mode. This is a little bit redundant. We already chose what type we're going to use. Now we're just going to set it in the parameters. We selected ESC telemetry base. Now we need to go to this parameter and set it to 3. Okay. So our mode here is not throttle based. It's going to be ESC telemetry based. So we'll write parameters there. Okay, great. Let's go back to the web page. Okay. And at this point, we've set up our harmonic notch to a certain extent. Okay, so let's go to the little doc reference here. We did the initial parameter, set the low pass filter. We did our notch filter type. We enabled it. We enabled this. It should say in parameters. Okay, and then we need to do a test flight. Okay, so we need to go out and fly with these settings, and then we will gather a log that will help us understand the settings. Now, but don't take off flying yet. There are some parameters we need to set before that test flight. Okay, so parameters, right. So let's go over to the web page again. All right, so with the flight we want to do, we have to log some data at a different than default settings, basically to gather enough data to really be able to analyze this. Okay, so let's go ahead and go to this filter review tool. I think this will take us, no, sorry, that's the wrong one. Some of these links, let's see, here we go. Checking notch filter effectiveness. Okay, I'm just trying to get to this page, and I will make sure I get some links in this Word doc for you so you can find these links easier. But the raw IMU login for FFT analysis, this helps us understand how to set up our login for this tool we're going to use to analyze the logs, which is a different analyzing tool than what we normally use. Okay. The raw IMU logging basically allows us to log a lot more data than we normally would, and that helps with the analysis of the filters. So filter setup process. Okay, that's where we're going to jump to next. And this is why I want to make a video to kind of help you navigate around. I had to click around a couple different links in the wiki to get the flow of how this is supposed to work. Okay, so we're going to set up our filters, or set up our filter logging, I should say. Okay, because we've already done the method of moving the filters around. Okay, we've already selected all that stuff. So now what we want to do, okay, is go to the second step, ins raw log op. Okay, this is basically going to turn on what's called raw logging. Okay, and that will allow us to gather the data we need. So let's go search for this parameter, ins raw log, raw log. Okay, and by default it's turned off. We're going to click on that parameter, set bit mask. And in the description here, it talks about making sure you restrict it to only the primary gyro and both pre and post filtering. Okay, if you log multiple gyros, it's going to be like a humongous log. You don't want to. The logs are really hard to download when they get really large. At least in my experience with this flight controller, trying to download via Mavlink, it just takes forever with the logs. So make sure you select in Mission Planner, bit mask here, log primary gyro only, and then pre and post filter. Okay. And that should set the bit mask to 9. So we're going to write params. Okay. Go back over the wiki. All right. You're going to perform a regular flight, not just a gentle hover of at least 30 seconds. And I would say not more than a minute because the log gets really big. And download the data flash logs. So you don't want to go nuts and do a bunch of like huge throttle punches and stuff like that. But don't just sit there and let it hover in front of you. You know, fly around in some kind of lazy circles or something like that. And just do a normal flight in that sense. Okay. So once we've done that, we're going to then download the data flash logs. And they will be big logs, I can tell you that. You may, if you have any difficulties downloading them via the traditional way, in our data flash log download here, if this is just taking forever to download whatever log you're talking about, you may need to just pull the SD card out of your aircraft and manually, pull the logs off the SD card with your computer, and make sure you power the aircraft off before you pull the SD card out and stuff like that. But I did have some difficulties with the data flash logs being really large, and they're not working very well through this downloader, or at least just taking a very long time. Okay. But we're going to go ahead and download our logs, so I'm just going to pretend I already did that. I did my test flight. I have some logs here we're going to use for the filter tool. Okay, we'll go back to the web for a second here. We're going to use the filter review tool to load the log. Okay, select a steady hover portion of the log. So this is kind of the part where you don't want to do a bunch of crazy maneuvers. You don't want to just do a gentle hover, but you need a steady hover portion of the log to analyze. So it's kind of a, I don't know what you want to call that. Don't just gentle hover, but you do need a steady hover portion of the log. And we're going to calculate and watch that log viewer work. Okay. So let's jump over to the filter review tool itself. Okay. Looks like this. Okay. And you can see here it says browse, no file selected. So I'm going to go ahead and browse and go to my flights here. All right. So a couple of different flights, excuse me, that I was doing with this a few weeks ago or a week or two ago. And we're going to go ahead and grab this 42 Hertz low pass filter bin log file. That's the one I finally got right when I was trying to figure this out. Okay. So it'll take a minute to load, especially if it's a big log. And I probably should have been a little bit calmer with my flight. You can see here, once you load the log, okay, it will populate these settings up here. It's going to show you this graph here, and all these little question mark things will give you some hints about what basically what the setting box is for. Okay, and so in this case, we want to select a portion of the log that's relatively stable. The only really stable part I have here is this section here, so I'm going to click and drag a box around this portion of the log. Okay, and then we can scroll down a little bit further here. Okay, and we can see this graph of the IMU spectrum. Okay, we only have one gyro logging because we selected only primary gyro. That's good. Okay, we have pre-filter, post-filter, and estimated post-filter. All right, so if you double click on the words here, it will unselect or select all three boxes at the same time. If you click on one at a time, you can do that too. So you might kind of recognize this from checking our vibrations. There's X, Y, and Z axes for the noise on the flight controller here. Okay, and so what we want to do here is we will be looking at pre and post and estimated post as well in this graph. Now, I find it easier, at least for my brain, I guess, to view the amplitude scale in linear. Okay, it just kind of helps me to understand what's going on better. I'm still not very good at understanding dB and stuff like that. Always learning, right? But I would select linear scale here, and it kind of makes it more into the graph like I was trying to sketch out earlier with this drawing. So if we go up here and we look at pre-filter and post-filter, I'm going to go ahead and take post-filter off for a second. Okay. So pre-filter, this is the noise on my aircraft, the vibrations on the aircraft before any filtering is done. Okay, and so we can see I have some little peaks of noise, okay, around these different frequencies, around 100 or so, around 200 or so, around 300 or so, a little bit around 400, and then it kind of smooths out there anyways. Okay. Now if we look at the post filter, okay, and take the pre-filter off, we see the line's just flat, dude. There's hardly any bumps at all. I mean, if you select this area right here, it's hardly anything. Okay. Go back to home, reset the axes. So that's good because it means the filters are doing their job. They're getting rid of all this extra noise we don't really need. And most of the noise in our case, as long as we have a clean build of our quadcopter and not have a bunch of wires flopping around and stuff like that, is going to be from the motors. Okay, the motors are always spinning, so we can just tell the flight controller, hey, ignore that noise from those motors because they're always going to be spinning. There's no reason to worry about them or try to compensate for them. It's not like it's a wind gust that's blowing the copter off to the side where you want to try to compensate for that. Okay, so in our case, these are typically motor vibrations or things like that. It could be other things on the aircraft that are vibrating too, but we really try to minimize that by making sure everything's nice and tight and snug on the aircraft. Okay, so you say, well, this is pretty good, Duke. It looks like a pretty good graph. Yeah, it does. There's not much noise after the filters are applied. Okay, so that's good. The name of the game with filtering basically is try to do enough filtering, but not too much. You're trying to find that, happy medium because just throwing a ton of filters on, a bunch of harmonics and all this extra stuff may get rid of your noise, but the more filtering you do, the more latency or the more lag you introduce in the system. If you think about filtering water, for example, if you're ever drinking out of a water bottle with a filter built into it, you try to suck the water in, and it's harder to suck the water up the straw or whatever because the filter is filtering at the same time as you're trying to drink it. Similar to that, if we put a bunch of filters on the information that's coming into the flight controller, it slows that information down, and then it's harder for the flight controller to actually control the aircraft because the information it's getting that it needs to act on is now old, right? Because it already happened. If it happened a long time ago, then it can't act on it now and still control the aircraft very well. So we're trying to get information through the filters as fast as we can, but without letting too much noise through. So we're playing that game where we walk the line of we need enough filtering to get rid of the noise we don't want. We can't put too much filtering on or else we get too much delay in the system and the copter won't fly well. So if we go down here to filter configuration, okay. Oh, sorry, one more thing up here on the graph. You can select show notch number 1 and it will show you where the harmonic notch is applied in the graph here. So if we turn the pre-filter noise back on, you can see it targeted that peak right there. The first notch targeted it, which is what it's supposed to do. Okay. Let's look at the other settings here though. Okay, so the low pass filter, INS gyro filter is at 42. And that's because that's what we set in the initial tune parameters. Remember we typed it in here. Let's see, 10. We hit initiate parameters and it said, oh, INS gyro filter is at 42 or should be set at 42. That's good. So we can see our parameters here that correspond to filtering specifically. And the cool thing about this tool is you can go in here and you can change things. And you can hit recalculate filters and we can look at the estimated post filter and see what the tool estimates would happen if we change these settings without having to actually fly the copter over and over and over to check the settings. So that's the really nice part, as well as the nice interface, user interface here. It's, I think, pretty easy to use. Okay, so our INS gyro filter set to 42 is what's recommended for our prop size, so we'll leave that one alone here. Okay, but what we can do as well is we can change some of these other settings to try to reduce the filtering amount, so reduce that delay or latency in the system, while still filtering all of this noise out. Okay, so again, if we look at post filter, okay, it's pretty much flat. So at this point I'm going to turn on the estimated post filter, okay, and we'll see if there's any differences between what was actually happening, and as we change some of these settings, we'll see what it estimates it would do. So would we still get a nice flat graph, or would we start letting through some of that noise if we tried to back off on the amount of filtering we're doing, if that makes sense. So this one here, if any of these, if you hover over the words, it will give you a little description of what that parameter is for. Okay. This one's interesting here. It says this is the minimum. So if you kind of read down the third line there, I can't move my mouse or else it'll disappear. But this harmonic notch frequency is the minimum limit of center frequency variation for all other notch types. Okay. Other than static notches and throttle-based notches. So it's a minimum limit of center frequency variation for a harmonic notch like we're using. Okay. It says it should always be set lower than half the background back-end gyro rate, which is typically 1 kilohertz. Okay. So the minimum, the minimum limit means a harmonic notch center frequency variation, okay, shouldn't be able to go below 80 hertz. Okay, in this case, it's right about 100. We saw that with the little peaks here. Okay, but this harmonic notch, if there were a peak at say 60, the harmonic notch shouldn't be able to go down there because we already limited it to 80 as the minimum limit. Okay, so we don't need to worry too much about changing that one around. I think we'll leave that as is for right now. Okay. But we'll go down to some of these other parameters and look at them a little bit. We do want to leave these the same as well, since we already determined that's the type of notch we want to use. We do want it enabled. We do want ESC telemetry, so you don't have to change those. This one here, bandwidth, okay? This is basically how wide the filter is, okay? If that makes sense. How large it is in terms of width. If we imagine it on the graph, you know, is it going to cover from here to here? Is that a 40 hertz notch filter? How wide is that filter happening? Let's go over to our paint graph for a minute here. So let's see. So if we have a notch filter come in and go like this, okay. I'm just eyeballing it. Let's say that looks like about, let's say the width here, 100 hertz. That's a huge amount there, but that's the width there. So if we were decreasing the bandwidth of the filter, it would become more narrow. Okay, so maybe it would be more something like this. Okay, and maybe it's a 50 hertz. Okay, my scale is probably way off, but if you get the idea, that's the bandwidth. So we're narrowing or widening the filter, if that makes sense. Let's go back over here. So that's something you can try out. It does say here that the typically set to half the base frequency. Okay, this base frequency here, so 80 divided by 2 is 40, right? But we can decrease that if we want to and say to go 20, because what that will do is it will make the latency decrease in the system. If the filter's not as wide, it won't cause as much delay. Okay, so once we change something like that and click out of the box, we hit recalculate filters. Okay, let's do that while we're watching the graph here. Okay, so let's see if we see any changes. Actually, let's turn off the pre-filter. Okay, so we just see the post filter and estimated post filter. So let's recalculate the filters and see if we see any change in noise. I didn't really see any change. We of course could zoom in like this and see if we saw any changes. I don't see much change between the, let's look at this area here. Okay, let's look at estimated post filter. Oh, okay, actually there is some change. Look at that, a little bit. Okay, so the actual post filter, so what it actually flew with, where the bandwidth was 40, the end result was this. This is what actually happened, right? But the tool is saying, well, if I decrease it from 40 to 20, I click on this estimated post filter here, it's saying, well, look at that. That red line came up quite a bit more than the others. Now, quite a bit more is relative. The amplitude here is like minuscule, but you are able to see a difference the tool is estimating there between what actually was flown and what it might look like if I were to fly it with the bandwidth cut in half. Okay, let's try cutting it in half. Let's try fourthing it actually. So we're going to change it to 5. Recalculate the filters again and see what happens. Okay, good. So it's showing us more. It's growing there. Okay, there's more noise getting through because the filter is more narrow, so it's not able to capture all the noise. Whereas if it's wider, it captures all the noise, filters it out, but you have more latency in your system. So that's one thing we can alter there. I'm gonna go ahead and put it back to 40. Okay, so we just do one thing at a time here. Okay, so we should see the estimated and actual post filters are identical right now. So we change the settings back to what they were. Okay, this one here, the attenuation. Okay, um, basically when you attenuate something, you kind of, I guess we'll say, weaken it to a certain extent. Okay, a greater value here will produce a hard notch. Okay, a more okay, say rigid, or let's see if we can draw it. I'm not very good at describing these things. Let's see here. Let's get rid of this other stuff. Okay, so in my mind, anyways, and I am not an expert on this filtering per se, for sure. But as we have the notch come down, it typically looks kind of like a V, like this. Okay, so a hard notch will be more of a stiff area, I guess you could say, around that notch, rather than kind of a softer flowing notch, if that makes sense. I know that's kind of we're visualizing this, which we can't really see in real life. But if we increase the attenuation here, let's say we take it up to, actually let's try decreasing it first. So let's make it a softer notch. Let's just say take it down to 5. Okay. Let's recalculate our filter, see if we see any changes. Okay, so again, we're seeing more noise getting through because the filter is softer, if that makes sense. It's not as crisp. That's the word I was searching for earlier, crisp, of a filter. Let's go back to, I think it was at 40. Was it 40 default? I can't remember. Should have looked at that better. I think it was at 40. Okay, back to where we started from. Okay, if we were to go with a even higher number, we should get more of a crisp edge on the filter. Not really see much difference there. Perhaps if we reduced the bandwidth and increased the attenuation there. Let's see. I'm trying to get a visual difference here so we can see it. So we reduce the bandwidth. Let's reduce the bandwidth all the way down to like 5. So we see a large amount of noise getting through, for example. Okay, there we go. Almost 0.005. So again, large is relative, but let's increase the attenuation here up to 100. Okay. And see what happens. Nothing happened. I guess the filter's too narrow to really affect it. So not seeing much there that I thought we would. If we reduce it down quite a bit, we can recalculate the filters that way. We'll see the notch increased from where it was at before. The softer filter there let more noise through. So sorry if that wasn't the best visualization of the attenuation parameter there, but hopefully it helps you get an idea a little bit about what it's doing. So again, we're playing the game of trying to reduce filters, but still have enough. Okay. Let's go down here, the reference. Okay. This is something we're going to leave alone because it is already set to basically move around. Okay. All right, so you can see there about the 4th line down, it says for RPM and ESC telemetry based tracking, the parameter set to 1 to enable the harmonic notch filter using the ESC telemetry to measure rotor speed. Okay, so basically leaving that at 1 means the notch can move around based on RPM of the motor. So we want to leave that turned on. Okay, this one here, okay, this is basically a ratio we don't need to worry about too much because it's for throttle-based notch, uh, generally speaking. Okay, number of harmonics. Okay, this one we may want to play with a little bit. Let's see. So harmonics are basically like what we see here. Let's go back to this and pre-filter, turn off the post filter. Okay, so these peaks here, so you see one's at 100, this is a close to 200, then close to 300. Odds are those are harmonics. Okay, so if there are vibration or noise at a certain frequency and something's vibrating, it will also generate vibrations at harmonics of that first vibration. It generally will go, 2 times, 3 times. We see a little bit here at 4 times. Okay, so if I were to enable the second harmonic, okay, recalculate our filters, you see the second harmonic appear there. Okay, so 100 and then 200. All right, if I were to do third harmonic, let's say third, harmonic, fourth harmonic. Okay. Recalculate filters is going to stick notches all over the place. 1, 2, 3, 4. Okay. Each harmonic or each extra notch you add introduces more lag. Okay, and it makes the processor work more on the flight controller. And in this case, since our low pass filter, okay, is set to 42 hertz, it's coming in and cutting out these upper notches anyways, these upper peaks anyways. So we don't really need all these harmonic notches. Okay. Now you could play with something like moving the low pass filter much higher and just using notches to take care of these peaks. We're not going to worry about doing that in class as part of our assignment per se, but you could experiment with that if you wanted to. The low pass filter moving it to a higher frequency range can reduce lag in the system and get higher performance out of your aircraft if done correctly. But for now, we're not going to use all these harmonics because our low pass filter is already getting these notches anyways. We don't need to worry about getting those. And we can see that because we look at the post filter and say, well, oops. Well, those notches are all gone anyway, so no need to apply, sorry, those peaks are all gone anyway, so no need to apply extra notches because the low pass filter is already taking care of those. Okay. What we can do is go down here though to the INS harmonic notch options. Okay. There's a couple different options here. I think we have these on the wiki page. Let's go back. Here we go. So this gives you some good description of all the options right here, which I think it may also give you if you hover over them. Yeah, it gives you it there as well. And this is a little bit easier to read. Okay. So one of these options here that we're going to be using is called multi-source. And if in ESC telemetry mode, each motor will have a notch assigned at its RPM. So if you don't have this selected, it kind of averages all the notches. Okay. If you do have this turned on, then you have one notch per motor. Okay. Up here, it talks about the software notch filters are very spiky or relatively narrow. Okay. It gives you some tips. Larger copters, typically going to be talking about copters larger than ours, so ours would be large-ish, I guess you could say. Okay. It's quite dirty, so there's a lot of noise over a broad area. And so you can do things in these options here to help cover all the motors or a wider area of noise or things like that. Okay. We're going to use multi-source with our ESC telemetry. We'll have one notch per motor. Okay. And then this other option here updates the filters at the loop rate. This is CPU intensive but tracks noise variations faster. Okay. Excuse me. This is only valid if frequency source updates at loop rate using bidirectional D-shot. Okay, so what this is saying is the control loop of the aircraft that's running all the time, it will update the filters at the same rate as the control loop instead of a slower update. So this is better because it tracks things faster. Basically, we're following the noise faster because we're updating things faster as we're flying. Okay, you can only use this if you're using bidirectional D-shot apparently, which we are, so that works great. Okay. And so we're going to be using options 1 and 2 here. We're not going to worry about, excuse me, on notches on every IMU. Okay. I mean, you could do that if you wanted to, but we're not too worried about, I guess, redundancy, if that makes sense. We could enable it. I haven't flown with that. Maybe these 3 options would be good, but at least these 2 work well. We don't need triple overlapping notches. I don't think that's necessary for ours. Because we don't have that much noise. Our copter isn't that big with a really wide, dirty area in the noise profile. Okay, so we're going to go over to our filter review tool. I'm going to say multi-source, update at loop rate. Okay, and that sets our options to 6 here. So we're going to go ahead and recalculate filters. Okay. And the graph looks pretty much the same because we're looking at post filter, of course. There we go. Graph looks pretty much the same. Not much is going to appear to change there. But then again, at this point, you can start experimenting with decreasing the bandwidth and attenuation. You can even move the gyro filter around a little bit if you want. Okay, but all in all, we're looking for a nice clean result. Okay, from our graph there. And let's look at post filter. Let's look even a little bit closer here. I'm kind of curious if the multi-notch affected it a lot. Okay, so post filter, estimated post filter. Let's go and unselect multi-source and recalculate filters. Okay, so a little bit of change there. Interesting. It's nice to have the notch on each motor just because the motors are doing different things. Looks like it does have some effect here. And of course, I still have my bandwidth and everything pulled way down, which you may or may not need to do that. Okay. Well, this video is getting pretty long. Let's see here. Let me try to wrap it up. Let's go back to our web tools here. Okay. So we selected notch filter. We did a test flight. I've just showed you how to do some log analysis. Adjusted some filters in the estimate or the estimate. Okay. Here in the log viewer tool, we've been using the estimated post filter option. Okay. There's some other parts of the tool down here. You can see there's a spectrogram for the IMU as well. Okay, and the frequency response of the filters. Okay, what's happening here? If you hover over the question mark here, solid line shows average, shadow shows the range of movement as the notches track up and down. Now I'll admit I still don't entirely understand these graphs very well. Okay, but what we're trying to do, like I said, is balance the filtering. Okay, enough filtering, not too much because it will introduce a lot of lag into the system. Okay, and so these filters are moving around a lot. That gray areas, they're moving around a lot. Okay, and so as we play with these values, let's take this, for example, back up to 40. Okay, you also see the amount it's moving change quite a bit. Okay, this filter is not moving all over the place nearly as much as it was before because it is now wider. Okay, and so you can use that graph as well to kind of visualize how much lag you're introducing into the system, how much the filter has to move around, and how wide it is, that kind of thing. I'm definitely still learning this stuff and how to use this tool as well. So if you find out something new that is awesome to know about this, please let us know in class, or please let me know. But in terms of the process here, we have found an estimate that appears to look good to us. You want to do one more verification flight, so fly with those settings and see if it looks good. Now, if you've changed the settings in here, okay, and you've experimented and found some ones that look good on the graph, what you can easily do is you can actually save parameters. So just hit this button here. It's going to save the parameters you were testing with, and you can then take those parameters. Okay, so we'll save here, and take those parameters to your copter. Okay, go into the config menu, full parameter list, and say load from file. So I can load those parameters from the filter tool. Okay. It's just telling me I'm missing these ones. Harmonic notch number 2, that's okay. I don't have 2 harmonic notches, that's okay. So I hit OK. It's going to load those parameters in, and it doesn't really show you anything when it's doing that, unfortunately. But you give it 30 seconds or so, and you can search out one of the parameters if you want. Let's see here. INS harmonic notch bandwidth. Oopsie daisy. Okay, and now we can see that it has changed them. They're all green, right? It changed them from the defaults. And so if at this point, if you wanted to use those ones that you tested in the tool, okay, you can just go ahead and say write params, right? And now you've taken the params from your estimated testing in the web-based tool, you put them on your actual copter. You're then going to go fly the copter to the verification flight, and when you fly the copter again, you'll come back, you'll have another log, right? And you'll load it into the filter tool again, okay, browse and load your new one in, and then you can see how you did. And see, look at your noise and everything just like we just did now, but it'll be the second time. Okay. If that's all looking good, then as far as the assignment goes, you want to explain a bit of how you did things. Take some screenshots of the logs in the filter tool, okay, and tell me why you adjusted things, how you did, what you adjusted, why you thought it was going to help. Did it help? Did it not help? Did it make it worse? Whatever happened in the course of you doing this assignment, you'll want to explain that to me. Okay. One note again, as you finish this up, okay, let's go back and go to this one here. Let's see. Oh, this is why I wanted to lead you guys through this because it's kind of confusing sometimes. Notch filter. No, that's not it. Apologize. Where was the... Oh, here we go. Raw IMU logging. This is the page we were at before where we set this parameter. Okay, INS raw log opt. Okay, once you're done with this whole filtering assignment process, okay, you want to make sure, down here it talks about them, clear the parameter to avoid the huge logs, okay, because this will make very big logs. Once we're all done, we want to go back in here and, oops, go to this parameter again, click on it, set the bit mask, and deselect both of these options. Okay, and then we'll just have our normal logs again. They won't be huge, and we won't need them to be huge because we're not trying to analyze the data anymore after we finish this process. Okay, so that'll be the end of the assignment there. I'll add some more notes here, like I mentioned. This is just a kind of skeleton for this video to help me stay on track. All right, that should help you get through the filtering for your Ardupilot. Let me know if you have any questions. I will chapter this video appropriately so you can jump around a little bit inside the video as well. Thanks.